Hey guys, this is Arif from TechShare. Today I am going to share quick sort algorithm, how to basically work with quick sort. This quick sort algorithm works so that you guys can understand it. It's pretty simple, pretty straightforward thing. So before jumping into this topic, so I wanna share one more thing is I probably will create a playlist having all the data structure related videos so that you guys can get some help in there. At the same time, I also sometimes require a lot of different algorithm that I sometimes forget and I need to go and explore things. So if I put everything in place, that would even help me as well when I need to basically understand certain things. All right, so let's jump into the quicksort. So quicksort algorithm. Before explaining, I need to tell you that quicksort is basically the one of the best sorting algorithm out there that potentially has the most performance, and space complexity is also pretty good because it doesn't use a lot of memory as well. So in terms of time complexity and space complexity, I guess it is order of n. It is not n square. Order of n log n, I guess, because it also has some other additional recursive calls. Yeah, so let's jump into there. So how quicksort works? This is the interesting part. So let's say there is an unsorted list like this. So I have added here 10, 8, 9, 1, 5, 2, right? So quicksort works is this way. So we need to find a position here. So let's say the position is here. So let me put a drawing, free drawing here. So let me add something called drawing and then use this one. So let's say this is the position that we figure out. I will explain how we can achieve there. So let's say this one is the position. Now what we need to make sure is rearrange this list in a way that all the value that you have here on the left side needs to be less than or equal to of this value that you have picked here, and on the right side you need to arrange this list in a way that all the values which are greater than of this particular position value needs to be placed there. So if you basically do that, then what we can then do is we can iteratively call the same function again and again, and basically we can solve the quicksort, or we can sort it like quicksort. So we have here now two sets, right? So this is the set and there is another set. So even though this was not reorganized at this moment, but um, we have to reorganize in a way so that we have it, all the values less than of this particular value would be on the left side, and on the right side it would be all the value which is greater than. So yeah, this is basically the quicksort algorithm, and we are basically now writing this function so that you guys understand how to do this. All right, so now I have written this function called quicksort. So I'll basically I'll share the Visual Studio, and then I can basically run and debug the solution. But for now, let's jump here. So I have created this function called quicksort, and this quicksort function basically will accept the unsorted list, which is our array, let's say A, and then we also need to call the left and right position. So this is left, which is 0 when you will call it initially, and the right would be obviously um, the the length of this array minus 1, because it is a 0 based index, isn't it? So now this is the function. In this function, we are going to do is first of all, we need to create another. So this finding this position is very important, isn't it? So it is not only finding this position, you also need to rearrange this list in a way that all the values less than or equal to of this particular mid position would be there, and right would be all greater than. So we have to do this. So for doing this, let's just create another function here down this called let's say partition. All right, so in the partition we basically need the same value, which is array, and then you need the upper and right, and the job of this function really be to give us the index value, something like this. So this one, if we consider this one here, is this 1 which is sitting at 0 1 2 3. So 3 index, third index of this array, isn't it? So we need that index written from here, and when we'll return that one, we'll also rearrange this list in a way so that it will not only return me the index, it will also rearrange the list or collection or array. So let me do, how can I do this? So here, you have the left position, and then you have the right position. So let's just make a for loop here. So we can say integer j equal to 0, sorry, j equal to left. Left is whatever the 0 or the thing that you are going to pass. Obviously initially it would be 0, and then this j less than would be right, and we will increase the j by 1. And now here, this is a very important thing, we actually need this right. So what we are going to do here, when we will basically rearrange this list to greater than or less than, I guess the easiest option is you have to first basically compare with a value here and then basically reorganize this one. So let me put it here, then you will understand. So let's call a, a variable called temp, let's say, or t, and then we are going to pass this collection array of the right position, whatever the right position it has. So we basically take the value under this t. Now here we'll check if uh, the array of j, which is obviously at the very beginning 0, is less than or equal to the t value that we have on the right, very right. If it is, then we are going to do two things. Very simple. We are going to swap. Swap means, what is swap? I'll explain, but yeah, you also understand, I believe. So we are going to swap the A array with the position I have I and j. Now, what is I? I did not obviously declare the I here. So let me declare the I here, integer I equal to 0, right? Then when the swap will done, then we basically go I plus plus, and then when the loop ends here within this for loop, we also need another swap, which is basically say, hey, take the A array and again do the swap between I and right. That's it. So let me write the swap function here, and then I guess that would be it. So let me put it like 20 so that it fits here. So the swap function is pretty straightforward. So it would be like something like this, void swap. Why it is void? Because array will automatically be swapped. The value would be swapped within the array, so you don't need to return anything. So similarly, it would be a, and then integer I, integer j, and then here it would be simply you have to introduce a variable called temp equal to a of I, and then you can say then a of I position would be replaced with a of j, and then a of j position would be replaced with the temp value that you have basically set before. So this is basically the swap happens. So now what is happening? What is doing on here? So in this partition is doing this magic. So it will finally return the index of the I, because that is basically the position we already discovered. So this I, the return is I would be the position where all the values that placed on the left side are already sorted by less than equal to of this value, and on the right side everything is already greater than or greater than of this particular value. So yeah, so this I is basically the index of that particular position of that array. So yeah, so then what you need to do is here basically you can call this partition with a, and then left would be obviously your left and the right, and then here it will basically return your mid position. So we can say whatever the mid it returns, it is there. And then you need to basically call this quick sort again with the value, obviously the collection A, and in this time the left would be left 0 initially, or whatever the left, and right would be this mid -1. And this is basically you are passing this first section, like this first group, again calling the same quick sort, and we also left this right group, so we need to call this quick sort, then pass the A, and then in that case you need to pass mid +1. So we are basically not taking this one anyway, it is always missed, so we are not going to consider this one. We'll always take the remaining left, remaining right, and then this would be your mid +2 right. So that's it. So what will happen is, once you find this position, and this position is already, the list is already sorted in a way. It's not sorted, but at least you know that all the values that belongs to this left side is already less than, and right is right, greater than. And then when you basically find those subsets, you just need to call those subset here in this way, calling the same function again, and then it will basically again do and find on organize all this list in a way that it will also consider a place where everything is left less than or equal to, right is greater than, similarly here. And then basically when it keeps doing this thing again and again, then you would see your list is sorted out. Only thing you need to have is you need to have a breaking condition here, so that your recursive function doesn't basically go basically doesn't run indefinitely. That will basically overflow everything. So we just need to put this condition here, so it will only continue when left is less than right. So if any time your index goes above right, then left, basically above right, then you don't need to basically consider. Anyway, now what is happening is if you now apply this formula here, this simple logic here, then you basically quite easily sort out this one. So let's just do this one here on the right side. So first of all, we just need to consider this one and apply this partition logic. The very first time that is happening in here, in basically in this line. So it is this line we need to first execute. So what happens, but this will basically give us the position of the array, and also it will make sure the items are sorted on the left, items are reorganized on the left and right accordingly. So how can we do this? So let's just apply this partition logic. So according to the partition logic, so let me just draw this one here. So your according to partition logic, your t value is basically, so this is your t equal to we say a of right is basically this one, left is this one. So left basically l equal to left equal to 0, and right equal to right value is so your right value is just 0 1 2 3 4 5 1 2 3 3 0 1 2 3 4 5. Yeah, right is 5. So now here integer a of right, which is 5, is 2 value t, right? Now here you have this integer I equal to 0 initially, and then you are basically looping through I equal to 0, left equal to 0 to right, until right, and then you always check if a of j is t, which is basically means from here we are checking if a of 0 index, which is basically 10, is less than this right 2, which is not true, then the j will increase and comes here. Then we'll check if 2 is less than this right value, which is 8 is less than this right value 2. This is also not true, it will go here j. And then 9, whether it is basically less than 2, no. And then the j comes here, this on position, then it will check, yeah, this a of j here is basically less than of this right side or right position. Then what it will do, it will interchange this one with your I and j, basically get interchange. See here, so it basically interchanges between in the collection A, it will interchange I and j. So I has 10 and j has 1, so the new list we will have is this. The 10 and 1 will be replaced, so 1 will come first, and then 8 as it is, 9, and then instead of 1 we'll get 10 because that's swapped, and then 5, and then 2. This is the new list. So here, interestingly, our I basically increased to 1. So now my I is, so let me just draw it. So my I here is increased to 1, 0, and 1. And J is sitting here. And now J increase here, 5. Then it will check whether 5 is less than 2. That is not true. Then basically what it will do, it will do a final. So we have this for loop completed. Now it will go another final swap, which is basically anything that you have on the I position to the right position. So I position was sitting here, if you remember, and your right position is here. So the next swap would be this 8 and 2 will interchange. 1, then I position would be replaced with the right position, which is 2 would come here, and then 9 would remain there as it is, 10 would be there, and then 5 would be there, and instead of 2 we'll have now 8. So now we have a final list of this situation, right? The situation that we have on this list. So this is our basically the final situation. Now think about it. So we had this I. So we are basically returning the I. The position basically we are returning, isn't it? So the position here is this 2. So you can see now here clearly that on the left side we have all the values that is less than 2, which is 1. That's true. And on the right side, so now we have a situation where so we find the I we found here. This is my basically my mid position. This is my mid position. So we have every value which is only one value we got, which is on less than 2, and all the values that we have, it is not sorted though, but they are all greater than of this value of mid, which is right. Now what we'll do is with the left side we basically it's already sorted 1 and 2, so we don't need to consider this one. Then we have this the other set, which is 9, 10, 5 and 8. So let's just apply this one with our partition rules and see if we could get anything like the same recursively from here. So for if we apply this logic, because this is basically my right section, right, or right part. So right part, our quick sort algorithm will receive A, and we are basically using the left position, which is mid plus 1. So our mid is basically sitting at 1. So mid would be the left would be basically 2, and then our right value is again the same, which is the length of this 3, 4, 5. And now if we apply the same logic here, so what we need to do is it will basically take this 8, and then it will basically from 9 this one, so it will basically check on by one. So if 9 is less than 8, which is not, so the j will go here. If 10 is less than 8, which is not, then it will find 5. 5 is less than 8, which is true. If that happens, then eat this one and this one, because I sitting here, replace or swap, and then the new list would be 5, and then 10, and then 9, and then 8, right? And the loop will end, and then once the loop will end, then I position would be here, because I will increase here by 1. So 0 to 1 means here, and then the right is 8. So this 10 and 8 will replace like under this final swap, which would be 5, and then you have this 8, and then 9, and then 10. This is the position, isn't it? And then here your I will return, I basically sitting here. So this is basically my new I, or mid, you can say mid. So now you can see here all the value here on your left you have 5, which is less than 8, and then all the value on your right which are already like greater than 8. Now you can see here if you put everything on your list that we had, so we had 1, 2, the first phase, and then the second phase we have this 5, 5, then 8, then 9, and then 10. So now if you consider this list with this list, then you would see this is already sorted. But it will keep applying the same logic until it gets sorted, and you will get basically a final list like this, which is basically a quick sort, or you already just applied quick sort algorithm and to sort out your unsorted list. I hope it would be helpful to understand, but if you have any idea or if you have difficult understanding of this algorithm, just let me know. I would be happy to explain one more time. In terms of time complexity, it has the order of order of n log n, I believe. All right, guys. Chat you soon. Bye.